Okay, your first lesson is about scientific notations. Currently, when you write numbers, you write them mostly in decimal form because everyone hates fractions, all right? That is a bunch of digits to the left of a decimal point. They represent whole numbers. And there's digits to the right of a decimal point representing parts of a whole. We have an example here. That's 6.75. What column is the 6 in? 6 what? 6 tens? 6 ones or units. Okay, so that's what this represents. You don't need to copy anything yet unless you want to. That's 6 units. What does the 7 represent? 7 watts? Tenths. Well done. 6 units, 7 tenths. What does the 5 represent? Hundredths. Okay, you all understand that. I didn't have to teach you anything there. Decimal notation is generally fine, but it breaks down when you're trying to write extremely large or extremely small numbers. It can be a waste of time and space. Does that look like a legitimate thing you should be spending your time on in a test to write all that? Would it be very easy to miss a 0 and completely stuff it up and be 10 or 100 out of the answer? Yeah. That's an extremely large number. That's 325 decillion. This is an extremely small number. All a waste of time. It's too long. And it's not a good use of your page space. So you can see there's a truckload of zeros taking up space at the start or at the end of the numbers. This is your first writing. These zeros that sit right beside each other that have no numbers between, they're called placeholder zeros. The only reason for these zeros' existence is to push that 325 all the way over to the left to show us how big that number is. What's the purpose of all these zeros here? It's trying to push the 6.2 all the way to the right to show us it's a really tiny number. Okay? So can you see these zeros don't have anything between them? If you have that, they're called placeholder zeros because all they do is move numbers about. Okay, so get that first blue thing there. These zeros that sit right beside each other, no numbers between, they're called placeholder zeros. You actually do kind of fit. We're going to vote about changing room after the recording. Real cozy. Okay, scientific notation. I've told you this is bad. This sucks. What is the purpose of scientific notation? Scientific notation is a shortcut for writing these extremely large or small numbers that we use in both maths and science. So, this is probably the biggest thing that you need for your cheat sheet or your notes. What does a number in scientific notation look like? It has the following form. You've got A. This A represents a number. I don't know what it is. You've got a number times by 10 to the power of something that we don't know yet. So get that little rectangular box for now, and I'll tell you what the A and N stand for after. So basically what we're working out is today, we don't want to write all this crap. We want to write a number, a time sign, a 10, and a power of some sort to represent that whole giant thing. Okay? So how do we understand this? A is a number that's between 1 and 10. And what does that A do? It's a number between 1 and 10, and it represents the numbers that are not placeholder zeros. So that A is almost like any of the numbers that aren't zeros. What is n? N is a power of 10, so it's small, goes up to the top right. N is a power of 10 that jumps the decimal point, right or left, in A to match the number that you want. Right now, that statement doesn't make sense until you see the example. So then I'll give you some time to add this. If n is positive, the decimal jumps to the right. If n is negative, decimal jumps to the left. So I'm going to put a little sticker here to give you some writing time to get down to here, please. A couple of minutes. A is a number between 1 and 10. N's a power that's going to jump the decimal point to where we want it to go. I'm going to scroll it down to here for now so I can start talking through example 1 so you can actually see how this translates to answering a question. I want to write 325 decillion in scientific notation. This purple stuff, this is right now just for me to help your thinking. What is the thinking? This is the number that I want. 325 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31, 33 zeros after it. What numbers there are not placeholders? You tell me. Yes? Good. What are the non-placeholder numbers? 3, 2, 5. Because that's the meat of it. They're not just pushing things to the side. What number between 1 and 10 is going to represent 3, 2, 5? Is 325 between 1 and 10? Is 32.5 between 1 and 10? Is 3.25 between 1 and 10? Yes. 3.25. Okay? That's my A. That's the little thing that goes at the front. All right? So I'm going to write the answer, start writing the answer at the bottom here already. 3.25 times by 10 to the power of, I don't know just yet. Okay? How do we work out what power it goes up to? We just said 3.25. So the decimal point is between, do you agree that the decimal point right now is between 3 and 2? Is it between 3 and 2 right now? How many jumps is it going to take? Because this giant number right now, where is the decimal point here? Right at the end. The decimal point's right here. I want the decimal point to be here. Right now it's over there. So I need to jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that 35 jumps? So it's 3.25 times by 10 to the power of 35. Why? How many times did I jump?
35 times.
35 times. It went to the right. How many jumps in what direction did the decimal point to match? 35 jumps. Can you get that example down, please? If you've already got that, have a look at example 2. Let's not write all that thinking. Any of you that are done already? What are my non-placeholder numbers for this one here? Is this an extremely large or an extremely small number? Example 2. Extremely small. What are the non-placeholder zeros but not you? Good. But I need 62, but as a number between 1 and 10. Good. See how we're not writing all that bloody thinking anymore? We're just getting to the point of it. 6.2, you don't get to choose whether you write times by 10. That's guaranteed. I need to choose how many times did I jump. Where is the... So your classmate said it was between 6 and 2. There's a decimal point between the 6 and 2. What direction am I jumping now? Left or right? Left, because my decimal point, this is an extremely small number. The decimal point's right there. So I need to jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that right? Just writing 14? What sign should it be? Negative, because I jumped to the left. Get that example down, please. While you're still copying down for the people that are faster, have a go at example 3. Is this decimal form or is this scientific notation? So we need to practice going back the other way. Hey, someone requested that you move here. You're only here because I said yes. As soon as I see the negative 12, are we talking an extremely small number or an extremely large one? Small. Good. If I'm jumping to the left and my number has to be between 1 and 10, how many jumps am I going to use to get over that units number, that 5? Any thoughts? Well, I'm going to jump 12 times to the left, but I'm trying to think ahead and go, look, isn't one of those jumps going to be used to jump over 5 to start off with? So it's going to be 1, and then how many zeros is going to follow? It's going to be 1 jump over 5, and then 11 zeros after to make 12 jumps. We can check. Let's go 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then write these numbers here, 5, 7, 0, 6, 5, 2. We need to double check that agrees with this. Decimal point is over here. If I jump 12 times back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is that right? Between 5 and the 7? Okay, always double check if you got time. Get that example, please. Yep. How far there? Is that enough? That's someone's phone. Hey, I'm not your care group anymore. I'm not squeezing your pouches every day, am I? It's 10 IG1s getting their pouches squeezed every day. Why is your phone that important anyway? It's not like if any of you are that loaded, you wouldn't be at school. Surely that phone would be helping you be, I don't know, not here. I don't actually think I need to go do the full notes at the bottom to come, because you're probably all quite tired. It actually makes a lot of sense if I just show it while these examples are up. So if I did this, scientific notation comes up a little different on the graphics calculator. Okay, let's do 5, just a really big number, times by, even the calculator can't be bothered writing the full thing, because does it have a limited screen space? So it doesn't have space to write the zeros. Do we have a number between 1 and 10? That's not written as a power. It's like full size, but that's the power. Does it have the times by 10? What if they replaced the times by 10 by? That's all they did, okay? So after this, the only remainder of the lesson is, so what have you done so far? You've learned how to jump the decimal point to the right, jump it to the left, and have you also seen how to convert scientific notation back the other way to a normal number? And then how does a calculator handle scientific notation if it can't be bothered writing an extremely large number? What does it replace the times by 10 with? E. It's not written as a power, it's just written as 17 next to the E, but it's the same thing, okay? Is it still a number between 1 and 10? All right. Any questions about that? Okay. I'll stop.